We have the account reloading vulnerability. On Solana, programs do not own the truth of account data automatically. When the transaction starts, accounts are loaded into memory once, and our program works with that snapshot. So, an account reloading vulnerability can happen when the program assumes account data hasn't changed, but another program rather modifies the state of that account mid-transaction, and the original program is still working with the stale data like the previous state of the account. Let's see how it affects this scenario. We have a yield vault, a staking protocol where users deposit tokens and earn rewards. Now, the architecture of this program is that we have a separate rewards distributor program, which via CPI credits this user as their reward. But what went wrong? This is the rewards program. Checking this claim and withdraw instruction, you see that balance is fetched first from the vault account on chain. We have a balance of 1000. Now we forge ahead to the CPI to add rewards to this account. Here, rewards of 500, let's take it as half of user's balance added to the account. And at this point, we have 1.5 for the user's balance. But the in-memory struct still shows 1000 because, like I said, we just have a snapshot of the account. We don't have the current state. So your current program is still working with the old 1000 instead of 1.5, which is a security flaw. And this check, if you run this check, you see that this check is triggered and you have an error insufficient form. How do we fix this? We have the reload function. So after CPI, we can apply the reload function so that we fetch fresh data on chain. So at this point, instead of having 1000 as we did in the vulnerable program, we have 1.5 in the new balance. And if you run this, it passes and can proceed to the next line of action. Yeah. So go to the exploit playground to test this out with real data. Here on the exploit arena, we can access the account reloading module, which provides us vulnerable and secure versions of this program where we can test the impact of this vulnerability in real protocols. Here we have a pool. Now, this scenario, we have a pool with this amount of liquidity, and we have users that have stakes in this pool. And the rule of the pool is that if 50% bond is applied each time you want to withdraw, so if a user requests to withdraw 1000 tokens, check here, you can see the calculation for the shares and see the initial balance is slashed into this. Now, you might ask, how does this concern this particular vulnerability, or how does this portray? Remember, remember in this instruction, you have balance that is loaded first. That's the same way here. Your balance is loaded first, and then CPI slashes your account to 567. But this is the secure version that calls reload. So it knows that we have 567 shares left, and when you try to withdraw, you see that you can't withdraw, you get rejected because half of this cannot cater for 567 tokens. Hence, a secure framework. But if you access the vulnerable parts, when your balance is loaded first, and then CPI does the calculation of 567 reward, but your memory or your account data is not reloaded, so your program still sees 1134 shares like your original balance, and this particular this particular program, which is the vulnerable program, still approves your transaction. You can see here, you can see the risk analysis impact where one is requesting for 1000 token and it's still approved, but on the secure part it's rejected because you can only withdraw half of your tokens. So asking for 1000 when your true entitlement is 567, this particular program rejects it, but the vulnerable program accepts it. You can test it out. If we try to execute the transaction and we approve it, you see 1000 gets added to the user's balance. But on the secure part, if we try to run this transaction, you can already see simulation failed to show you that it doesn't even go through. You see it's blocked. See post bond check failed, correct behavior. So This is basically what this exploit playground allows you to do. You can see code, you can test it out with real values to see impact on real protocols.